Alright class, so today we're going to look at arcs, chords, and inscribed angles. So let's get to our warm-up here. We have our circle P. We need to find the measure of arc MOL. So if we see where MOL is, it's all of this part of the circle. And because we know that angle is 150 degrees, we know that this is also 150. So that's a big chunk of what we're looking at. We also know that this angle here and this angle here are congruent. And we know that individually they add with the 150 to get us half of our circle. So 180 minus 150 is 30. So each of those angles is 30. So really all we have to do is take the 150 and add a 30, not 150, sorry, 180, and add the 30 to it. So that comes out to be 210 degrees. And that's our answer. Number 2, Diane runs around a circular track that has a radius of 55 feet. After running 3/4 of the distance around the track, how far has she run? So using our formula for arc length, it's going to be x over 360 times 2 pi r. So all we have to do now, instead of using x, because we don't know our angle, we know that she ran 3/4 of the length around it. So instead of x over 360, we're going to use 3/4, so 3 over 4 times 2 pi, and our radius is the 55 feet. So we plug all that into the calculator, and it gives us our answer. L comes out to be, does not say it around anything specifically, so 259.18 feet works just fine. Okay, here's your warm-up. Let's get into these notes. Vocab words for the day. We just got a couple of them. Inscribed angle and an intercepted arc. We'll get to those further on in the notes. They're not immediate words. Remember last notes, we had 18 out of our 28 words just in that one note. So here we have a theorem. This is in the same circle or in congruent circles. Two minor arcs are congruent if and only if their corresponding chords are congruent. So here we have circle L, and we have that FG and HJ are congruent. So that means the arcs FG and HJ are also congruent. Now there's a theorem proving that. If you want to look into that, you can. We're not going to go over that really, but you can check out the proof of that if you want. Here we have a piece of jewelry. It's a circular piece of jade hung from a chain by 2 wires around the stone. And it says that JM, so chords here, JM is congruent to KL, and the measure of arc KL is 90 degrees. That means that we need to find the measure of JM, and since we know that the chords are congruent, that means that the arcs are also congruent, and that means that the measure of arc JM is also 90. Super simple. That's it. Just basing it off of the theorem we just looked at. Okay, our next one here, we got 2 different circles, circle A and circle B. But we do know that the arcs are the same because they are marked with that little tick mark there, telling us that arc WX is congruent to arc YZ. It also says it in the problem, in the figure, the circles are congruent and that those 2 arcs are congruent. We want to find WX though, so now what we need to do, because we know that arcs are congruent, that means the chords are congruent. So WX and line segment WX, chord WX, whatever you want to call it, is congruent to chord ZY, or YZ. So we're going to set these 2 binomials equal to each other, solve for x, and then use that x in what WX is, so 7x minus 2, and find what WX length is. So we have 7x minus 2 equal to 5x plus 6. We're going to subtract 5x from both sides. So we have 2x minus 2 equal to 6. Add 2 to both sides. And 2x is equal to 8. And we divide by 2. And x is equal to 4. So that's our x. It's not what we're looking for. What we need to do now is take that x and plug it back into 7x minus 2 to get the measure, or get what wx is. So we plug that back in. 7 times 4 minus 2. And 7 times 4 is 28. Minus 2. And wx comes out to be 26. So that's our final answer. We don't have any measurement units here, so that's just going to stay as 26. You can put units on there if you really want to, but that's okay. Here's a couple more theorems here. We got that they're kind of the converse of each other. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. The alternative to that is the perpendicular bisector of a chord is a diameter or radius of the circle. So here you have the two images basically saying the exact same thing. So xz, zy in the first one. Z is not labeled in the second one for some reason, but they do intersect at z, and x, z, zy are congruent to each other, and they intersect AB at a 90-degree angle. So they're perpendicular. So here we have exactly that happening. This is a radius now instead of a diameter, but it still is the same thing. So we know that the measure of arc DEF is 150, so that's the entire arc there, and I'll draw that out for you if you don't see it. So DEF goes around the circle right here, and we are looking for DE, so this portion of it, the blue portion. And because that is perpendicular, as we can see by the mark saying it's perpendicular, that means that is bisecting the arc, or the radius is bisecting the arc, and that means that DE is half of DEF. Exactly. So we take the 150, divide it by 2, and we get 75. That's the measurement of arc DE. And that's it. Again, super simple. Next one here also has to do with the same concept, but now we have this ceramic tile. It's a very elaborate ceramic tile, maybe for a backsplash, I guess, anyway. So AB is 18 inches long. That's the diameter of the circle portion. And then the chord EF is a side of the square as well. It is 8 inches long. We need to find CD. C is the center. D is in the midpoint of the chord, because the diameter bisects the chord. So, since it goes to the middle of the chord, and it goes from the middle of the entire tile, CD is actually a radius, or an apothem, for the square. And whenever you have an apothem for a square, that's just going to be half of the side length. So we know the side length is the 8. So we just take 8, divide by 2, and our answer is 4. And actually we do have a measurement, or a unit here. Sorry, it's 4 inches. And that's it. Again, incredibly simple on these ones. Until we get to a real formula, it's going to be pretty easy. Or just basic algebra. Alright? So here we have in the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So here we have chord FG and chord JH, and they are congruent if and only if LX and LY are equal as well. And assuming that's the case here, probably is. Probably will be in this first example here. So we have 4x minus 3 being PQ, and 2x plus 3 being PR. We want to find what PQ is, so we're just going to set these equal to each other as they should be. and especially since it does say that the two chords are congruent. EF equals GH, which equals 24, so that's great, but that 24 is there to trick us, so we're not going to really use the 24. We are, however, going to use the two formulas inside, so the 4x minus 3 equal to 2x plus 3. We'll subtract 2x from both sides, so 2x minus 3 equal to 3. Add 3 to both sides. So we have 2x equal to 6. And we divide by 2. And x is equal to 3. So now again, this is not what we're looking for. We need this in order to find what we're looking for. And really it doesn't matter which one we plug it into, but we are trying to find PQ, so we might as well use the 4x minus 3. So PQ is equal to 4 times 3 minus 3. 4 times 3 is 12 minus 3, which is 9. And again, we don't have a unit here, so PQ is just 9. Alright. Got a few more examples to get through, and then our exit ticket. And we also have a few more theorems. So this is the inscribed angle theorem. This one says that if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So here we have points A and B on the circle, and they connect to a point on the other side of the circle that makes angle 1. Angle 1 is equal to half of the measure of arc AB between the 2 points. And vice versa, the measure of arc AB is equal to 2 times the measure of the angle 1. Alright, so we're going to use that for a couple problems here now. Here we have this figure. We're going to use the same figure for 2 problems. We know that we need to find the measure of angle X. That's inside this circle here. We mark it. It's right here. And ZW is the arc that goes along with it, and it's 86. So because that arc is 86, we just need to take the 86 and divide it by 2 to get our angle. So 86 divided by 2 is equal to 43. And we are talking about the angle here, so 43 degrees. Everything's in degrees here. So that's our answer. As simple as it can get. Okay, now, again, we're going to use the same figure. Now we're looking for the measure of arc YX. And that goes along with the 52 degree angle. So here's YX here, marked in red. So what we're going to do, instead of dividing by 2 like we did last time, because we had the arc, we were looking for the angle, now we have the angle, we're looking for the arc. So we're going to multiply by 2. So 52 times 2 is 104. And that's the answer for that one. Alright. I think we got 3 more problems to get through, and about that many theorems that go along with them. So here, if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So here you can see angle C, the 2 lines that come from it, or that make angle C, go to points A and D. Same with angle B. The lines making that angle go to A and D as well. So because they both go to the same points, that means that angle B and angle C are congruent. So we'll use that one now. We have this image here. I'm going to have to draw in there so you can really see what is going on here, but it says that we need to find the measure of angle R. So we're going to be using that 12x minus 13 here in a minute. But notice that R goes to T and Q, right? And let me get a different color than blue since the circle is blue. So S goes to Q and R as well. So that means They use that arc together, right? So because they have the same arc that they create, that means that they both are congruent. They both are congruent. They are congruent. So that means that 12x minus 13 is equal to 9x plus 2. And now all we have to do is solve for x and plug it back in. So we subtract 9x from both sides. So we have 3x minus 13 equal to 2. We add 13 to both sides. And 3x is equal to 15. And we divide by 3 on both sides. And x is equal to 5. So we got our x. Now we got to plug that back in to figure out what the measure of angle r is. So 12 times 5 is equal, or not equal, minus 13. 12 times 5 is 60, minus 13, and our angle comes out to be 47 degrees. Alright, so here's another theorem. Like I said, we got two more problems, two more theorems probably. I don't remember if there is one more theorem in between the last two. An inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So for here, if FJH is a semicircle, which we assume it is based on just looking at FH being a diameter, looks very diameter-like. Again, looks can be deceiving, but to make sure of that, that means that the measure of angle G is 90. So we have to know that that is a semicircle to assume that angle, or to know that angle G is 90. And alternatively, if angle G is 90, then FJH is a semicircle and FH is a diameter. So it just depends on what we are given and what, like every problem, just depends on what we're given and what we're trying to find. So here, we are going to be using that. We have AB, it's a diameter, so that means that arc AB is a semicircle, and that means that angle C is a 90-degree angle. So this triangle is a 90-degree, or a right triangle, and that means the other two angles also need to sum to be 90. So that's what we're going to do. We're going to add these two angles we do have information about, the 8x minus 4, and we're going to add it to the x plus 4. We're going to set that equal to 90. So 8x plus x is 9x. We got a negative 4 plus 4, that's 0. So 9x is just equal to 90 now. And then we divide by 9. And x comes out to be 10. Now we're going to take that and plug it into the binomial for the measure of arc B, or angle B. So that's going to be the 8x minus 4. 8 times 10 minus 4. 8 times 10 is 80. Minus 4. 80 minus 4 is 76. And we are talking about an angle here, so it's 76 degrees. Okay, we got one more example, and this has two parts to it that go along with this formula here, or this theorem here. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means that angle K and angle M sum to be 180, and angle L and angle N sum to be 180. So here we have an insignia that, by the way, an insignia is an emblem that signifies rank, achievement, membership, and so on. The insignia shown as a quadrilateral inscribed in a circle. So we need to find the measure of angle S and the measure of angle T. So angle S is going to be the easiest one because, remember, opposite angles are supplementary in this situation. So angle V is 90 degrees across from it. That means that 90 plus 90 has to equal 180. So angle S is also 90. So our measure of angle S is equal to 90 degrees. Already done with half of what it's wanting us to do. Now the other one, not so easy, but still fairly easy. Again, we know that the opposite angles are supplementary, so we have to add angle T to angle U and set it equal to 180. So that's going to be 8x plus 4 plus 14x equal to 180. Combining like terms, 8x plus 14x, that's going to be 22x plus 4 equal to 180. When you subtract 4 from both sides, 22x is equal to 176. And we divide by 22 on both sides. And our x comes out to be 8. Now, that's not what we're looking for. Again, we need to take that and plug it into one of these two formulas. We're looking for t, so that's going to be the 8x plus 4. So I'm going to have to write a little bit smaller here. 8x plus 4, 8 times 8 plus 4. 8 times 8 is 64. We add 4 to that, and that's our angle S, 68 degrees. So we got all of our angles here. Really, we didn't get all of them. We didn't find U yet, but we could, if we wanted to, just plug in 8 for x, multiply it by 14, you're done. Don't have to do that, though. It's not asking us to. So with that, here's your exit ticket. Get it done. It is exactly the same things we just did. The only difference is some of the numbers changed, and you got to find the measure of angle N down at the bottom. Find x, plug it in, solve, you're done. See you next time.